Hello guys, in this video I'm going to show you how to simplify radicals. Simplifying radicals is very important. You have to, whenever, you remember in that other video I posted, I talked about the index. So for example, if you have, let me not put cube root here, but let me just put something like the nth root of a. So I said the a would be the radicand and the n up there would be the index. So whenever you're simplifying radical, you have to be careful. You have to make sure you check what the index is. It's very, very important whenever you simplifying radicals. Why? Because whatever the index is basically what you're looking for. So for example, if I give you if I say to simplify the square root of 9. Now remember, I said that when it's in my other video, when it's the square root, you won't see a 2 written like this here. It won't be there. When you don't see anything, it means it's the square root. So always keep that in mind. If it's the cube root, you'll see a little 3 there as the index. If it's the fourth root, you'll see 4, fifth root, 5, you know. But if it's the square root, you won't see the 2. Okay. Now, square root of 9, anytime you check the index, so since I know it's a 2, I know that I need the square root of 9. So I need a number times itself that could give me 9. So that's the actual answer to this. A number squared that would give me 9. Okay? So in other words, if it's the square root, I could have tried to write this as the square root as something squared that would give me 9. So 3 squared. Okay? Therefore, the answer is 3. Okay? So it's that simple. You just need a number squared that could give you 9. Same way, if it's the cube root of something like 8, for example, I just need a number cubed. Okay? A number cubed that could give me 8. 2 cubed, that's 2 times 2 times 2, which is 8. So therefore, you know that the answer to this will be 2. Okay, so 2 is that number whose cube will give me 8. All right, so this is how you do this. Now, same way if you had variables. So let's say you had the fourth root of x to the fourth. Now, well, this will be x because that's the fourth root of x to the fourth. Okay, now this is pretty easy and you can keep going like this. You just need to make sure you have the index is the same as the exponent here. Okay, and therefore you can see what the answer is. Okay, now also it won't be that easy. You may see that the number you have there is not, it's not possible to get what you need. So for example, if you have the square root of number like 24, for example, okay, square root of 24. Well, I don't know any number times itself or any number squared that could give me 24. Okay, so it seems like there's a problem, but no, there's no problem. You can still break this down because you know 24 is actually 4 times 6. So the key is this. If the number you have here does not work, if it's not a perfect square, what you need to do is to try to find a perfect square as a factor of that number. So a perfect square times another number doesn't have to be a perfect square. So the first one must be, or second one, but one of them must be a perfect square times another number, which doesn't have to be a perfect square, that could give you what you had before, which is 24 in this case. So 4 times 6, 4 times 6 is 24. Therefore, this is okay, what you wrote here. Okay, so now you can keep going and you can break this down now into square root of 4. Now I'm just breaking it down. You don't have to do that, by the way. I'm doing it so you can see what where I'm going here. Now, I can do what I wanted with the 4 here because the 4 can be written as 2 squared, okay? It can be written as 2 squared times square root of 6. And now the square root of 2 squared is 2 and times square root of 6, so square root of 6. Now this can be broken down further. It's not a perfect square. 6 is not a perfect square. And it can be broken down into another perfect square and another number. So that's why you have to stop here. Okay? Because there's no other number or a perfect square from n6. Because factors of 6 would be numbers like 2 and 3, right? 2 times 3 is 6, but 2 cannot be broken down. 2 is not a perfect square. 3 is not. You can say 1 and 6. 1 won't help. It's a perfect square, but it won't help, okay? So you stop here, all right? Basically, you stop here. Okay. So this is just to show you that, hey, you can still do this. Another example I can give you, and I'm going to use a different type of index. For example, let me give you the cube root, and I'll say the same thing here. Cube root of 24. Now remember, this is not the square root, it's the cube root. I put a 3 as the index. Remember, I said the 3 is very important. Now, what can we do here? Okay, we look at this and we know we need a number times itself 3 times. That could give us 24, or a number cubed that could give us 24. We don't know such number. There's no such number. But the next step would be to try to break it down into a number which is a perfect cube, okay, times another number. Now you can use one radical, it doesn't matter, times another number. So now, in this case here, I know 24 is 6 times 4, but 6 is not a perfect cube, 4 is not a perfect cube. But 8 times 3, 8 is actually a perfect cube. Now, I'm saying 8 is a perfect cube because 8 is equal to 2 times 2 times 2, which is 2 cubed. So 8 is a perfect cube. Okay, so that's why I'm saying it's a perfect cube. So you needed a number like this. You got it. Now, the other factor is 3, because that's 8 times 3. Remember what I told you. If this doesn't make sense to you, you can actually write it this way for it to make more sense. Put 8 here times 3. This is the same 24 you had, right? Same 24. So you know it's pretty easy. You got it. You got the perfect cube. So this is cube root of 8 times the cube root of 3. Okay? And what else can we do here? Well, this can be written. If you can see it, you don't have to do all this, but I'm just doing it so everybody can understand this. 2 cubed, right? So it's 2 cubed times the cube root of 3. Guess what? The cube root of 2 cubed is 2. And cube root of 3 can't be broken down into a number times it's a number cubed that could give you 3. You don't have that. So that's just cube root of 3. And this is your answer. So this is how you simplify radicals, right? Now, I'm just dealing with constants, right? Actual numbers. So constants. How about variables? Well, you do the same thing for variables. Same concept, same idea, variables, right? So now, let me give you an example here. What if you had the square root of x to the 4th, y to the 3rd? Okay, well, we have the same idea here. It's the square root. Now, The other way to do this, which would make it very easy for you to do, is to try to find numbers that are divisible by what you have as the index, okay? The index is 2 in this case. Remember, you don't write the 2, but it's there. It's a 2. You will not write the 2. Remember that, okay? But I'm putting it here for you to remember. Now, all you got to do is finding numbers here that are divisible by 2. If you can get that, you just divide and that will give you the answer. Let me show you. So I can do that. I can find such numbers because 4 is already divisible by 2, so that's fine. Then I have 3 here, so 3 is not divisible by 2. I'm going to rewrite y cubed as y squared times y, because y squared times y is y cubed, okay? Okay, then I can keep moving. I can do, I'm going to put square root here of what I cannot do, but the ones I can solve, the ones I can simplify, I'm going to put them outside because I simplified them, which makes sense, right? So x to the fourth power, right? 4 divided by 2, which is the index you have here. Remember, don't put it there. I'm just putting it to explain. 4 divided by 2 is 2, right? So I'll have an x squared, right? Then y to the second. 2 divided by 2 is 1. Therefore, I'll have y to the first, which is just, you don't have to put the 1, right? Okay, then this one is y to the first, right? You don't have, 1 is not divisible by 2, and you can't break 1 down, so you have to leave it inside. Y is inside, okay? So remember this. You can keep going and keep reducing this until you get to the final answer. So this will be your final answer. Now, I'm going to take another example just to show you. Okay, another example. Let's say we have something like the cube root of -16 s to the 4th and t to the 9. Okay, now one thing to remember here, guys, is that if you had to find the even root, for example, if the index is even, for example, of a number here, a, now if the index is even, if n is even, then what you have here must be positive. Now, why? Because if it's not positive, you will not get a real number as the answer. It will be an imaginary number, okay? So remember that. So in order for you, if you're working in the real number system, if you have an even root here, the radicand here must be positive, okay? Remember that. Now, if it's odd, if n is odd, it doesn't have to be positive. Does not have to be positive, okay? Remember that. Does not have to be positive if n is odd. It can be negative, it can be positive, okay? But it does not have to be positive. Remember that. It can be both negative and positive. Okay, so knowing that, we can solve this. So if you see the square root, and by the way, the reason why I'm saying this is because if you had the square root of -4, for example, there's no number times itself that could give you -4. You could check 2 times 2, that's +4. -2 times -2, that's +4. So you would never be able to find this number in the real number system. So that's why we're saying this, okay? So keep that in mind. All right, so, but since this is a cube root, I know we can do this, right? Because it's a cube root. So let's go. Let's solve this. We have here, and I'm gonna try to split it so it could make more sense to everybody. Okay, I'm gonna put this right here, and I'm gonna put another cube root here with the things I cannot find, right? So for example, for 16, there's no number times itself that could give you 3 times that could give you 16, right? But in 16, you know you can find a perfect cube as 8 and another number, which is 2, because 8 times 2 would give you 16, right? 8 is a perfect cube. I'm using the 3 here. So I can use 8 right here. And I'm going to put 2 over there, because 8 times 2 would still give me 16, right? So far, so good. It's fine to put your negative sign here because you know it's odd. So we're okay. We're fine. We're good. It's good to go. Now, how about s to the 4th? I need something that's divisible by 3. Okay? It's 4. Since 4 is larger than 3, and I know whenever you multiply exponents, whenever you multiply two variables of the same base, you actually add the exponents. So I can split this into s cubed times s to the 1st, because this will give me back s to the 4th. Okay, I have to add the exponents, right? So therefore, I can put s cubed here and s to the 1st there, right? Same way for the t to the 9. T to the 9, 9 is already divisible by 3, so I don't need to break it down. I can just put t to the 9 right here. Okay, now let's go. Let's solve this. It's pretty easy now to solve, because the cube root of 8 will just give me, negative 8 will give me negative 2. Why? Because negative 2 cubed is negative 8, okay? Because that's negative 2 times negative 2, which is positive 4 times negative 2, again, which is negative 8, okay? All right, so now I go to the s cubed. S cubed, 3 divided by 3 is 1, right? So that's just s, okay? Then t to the 9th. 9 divided by 3 is 3, so it's t to the 3rd, because I got 3 when I divide by 9, okay? Then the rest is just cube root of 2s, because these two, you cannot break them down. So again, the answer is negative 2 st cubed cube root of 2s. Okay, that's it. Negative 2 st cubed times cube root of 2s. That's it. This is the answer, guys. So this is how you actually simplify radicals. Okay, you just learn how to simplify radicals given you have constants. You also learn how to simplify radicals with variables. Okay, so this is how you do it, and you can do this for any type of index, like 4th root, 4, 5, 6, whatever. That's what you do. Use the same principle, and I believe this is a pretty simple way to understand this or to simplify those expressions. Okay, thank you.